Subtracting polynomials is very similar to adding polynomials with one important change that can make it very easy to make mistakes. And so I'm going to show you, just like I did in the adding polynomials video, both the vertical and horizontal methods for doing these, because they're both good methods. But we have to be really careful with both methods because there's one really important change with subtracting and adding that um, that makes subtracting a little trickier. One thing you may have noticed in the addition video is that I basically ignored the parentheses. And the reason I ignored the parentheses is because whenever you're doing addition and you've got something in parentheses after the addition sign does not affect the parentheses at all. With subtraction, it really, really does. It really affects the parentheses. So let's start with the vertical method, just like we did last time. And this first set of parentheses that we have here, this 6y squared plus 8y to the fourth minus 5y, it does not have anything in front of these parentheses. So I can just drop these parentheses. Nothing's going to affect what's in the parentheses here. So I'm just going to rewrite this in order. I'm going to do it in standard form. So I'm going to start with the biggest exponent, 8y to the fourth. Then I'm going to do plus 6y squared because it's a positive 6y squared. That's why I'm doing plus. And then minus 5y. But the second set of parentheses, the 9y to the fourth minus 7y plus 2y squared, it does have something in front of the parentheses, and it's something that matters. It has a minus sign. And what that minus sign means is everything in that second set of parentheses is getting subtracted. The 9y to the fourth is getting subtracted. The negative 7y is getting subtracted, and the 2y squared is getting subtracted. You can think of that minus 1 or that minus as being a minus 1, and it's like I have to do the distributive property. So I'm subtracting 9y to the fourth. I am also subtracting negative 7y. And subtracting a negative is the same thing as plus, so I'm doing plus 7y minus times negative 7y is plus 7y. And then I'm also subtracting 2y squared, so minus 2y squared. So that minus sign makes a big difference. So now when I write this underneath the first polynomial, the signs are all different. So I'm going to start with y to the fourth, minus 9y to the fourth. Then I'm going to do minus 2y squared, and then plus 7y. I'm still lining these up just like I did before. And then I'm going to combine these terms. Now you may be wondering, wait, hold on, why are you doing a plus sign? Why are you adding these together? I thought this was a minus problem. It is a minus problem, but I already distributed the minus sign. I already took care of the minus by distributing that negative sign. After I distribute the negative, I'm just combining like terms. And this is something we're going to do in the horizontal method also. After you distribute the negative sign, we just combine like terms. And combining like terms is addition. So after I distribute the negative, it's exactly like adding polynomials. I'm just combining my like terms. So distributing the negative is the only new tricky part. If you make sure you distribute the negative to everything in the parentheses after the negative sign, you're good to go. It's just like adding polynomials. Okay, so let's go ahead and do this. 8y to the fourth minus 9y to the fourth is a negative 1y to the fourth, or you can just write negative y to the fourth if you like. 6y squared minus 2y squared is 6 minus 2, which is a positive 4. So positive 4y squared. And then negative 5y plus 2y, or spoilers, negative 5y plus 7y is a positive 2, so plus 2y, and there's our solution. Okay, so we distribute the negative sign and then combine our like terms. And that is exactly the strategy we're going to use for the horizontal method. That first set of parentheses doesn't matter. Doesn't matter, we can just drop the parentheses completely because there's nothing in front of the parentheses. There's nothing for me to distribute in front of that first set of parentheses, so I can just drop them. But the second set of parentheses does have something in front of it. It's got a negative. Minus 4n minus negative 3, which is the same thing as plus 3, and then minus 5n squared. So the signs of everything inside the parentheses changes because everything is being subtracted. After I distribute the minus sign, now I just combine my like terms. So let's go ahead and do that. Let's start with the biggest exponent, which is cubed. So I have an 11n cubed, and I don't have anything else that's cubed. So just 11n cubed. Okay, my next biggest exponent is squared. So I've got a 6n squared minus 5n squared. 6 minus 5 is 1, so a 1n squared, or just n squared. Then let's see what else we've got. I've got a 2n minus 4n. That's a minus 2n. And then all that's left is just that plus 3. And so here's our solution. 11n cubed plus n squared minus 2n plus 3. So the only tricky part of this is the negative sign in front of the parentheses. As long as you take care of the negative sign in front of the parentheses, it's exactly like adding polynomials.